Okay, folks, I think we can start now. We are 3 minutes over time. Thank you for coming here. I'm showing you today what you can do with a small little ESP32 powered display with a kind of PowerShell. First of all, as always, we have to thank our sponsors: Chocolately, Jane Street, Knowledge Factory, Ironman Software, and Synergy. Without them, this wouldn't be possible. So, a few words about me. Maybe there's someone knows me from my talk yesterday. My name is Frank Lindenblatt. I'm in the IT since 1984, starting as a hobbyist in school and later on as a professional in 1988. I'm currently working as a senior DevOps engineer at Finanzinformatik in Hanover, Germany. This is a computing center for the German saving banks. So if you ever come to Germany and pay with your credit card, all these transactions run through our computing center. My passion is, as you can see and have seen in the last two talks, PowerShell outside the mainstream. At work, I work with PowerShell normally as almost everyone, but in my spare time, I always try to do something special with PowerShell. And in this case, I'm working always with different languages, PowerShell and C#, or in this case, PowerShell and MicroPython. A weird combination, but we'll see what can be possible. So what I'm talking about is today, in this case, in this special case, a 7-inch human machine input device. It's an ESP32 powered touch screen. It's such a little gadget, USB powered, and one I have here on my desk, and I will show you in a few moments. So right now, my project is in a very early stage. I started this project in February this year, so there are almost only 5 months in my spare time invested in this project. So this is more of a proof of concept, what is possible, and I hope it gives you a rough idea what can be possible if I invest more time or somebody is interested and contribute. So what I've done is I've made a PowerShell module called PowerDeck. This is not the only one. There's another module lying below. It's called PSMPy tools, because the firmware which is running on this device, unfortunately, PowerShell could not be run on this device. I run MicroPython firmware on this ESP device, and this MicroPython firmware from the vendor and of this device includes graphics library. The graphics library is called LVGL, Light Versatile Graphics Library. This is quite cool because you can relatively easy design user interfaces, graphical user interfaces on such gadgets. In my case, this is the only one I found right now, which brings this out-of-the-box experience with MicroPython bundled with this LVGL library. There are other devices around which support MicroPython on its own and LVGL on its own. But if you want to use LVGL, you have to write a C code. And C code is not a problem, but you have more to invest in time and code and so on. So I looked around for a solution where I can combine a MicroPython with LVGL out of the box, because compiling MicroPython with LVGL together seems a bit problematic. I've searched around, found many problems and almost no solutions. So I was happy to find a firmware which combines it for usage. So this is all of the slides. Go to work, demo time. Perfect. So, what I have to say first is I had forgotten that before my journey to Malmö, I'm on vacation for a week right now and come to the conference. I had 2 bugs I needed to fix and I wanted to fix on this way here. I simply forgot it in preparation of the Posha talk from yesterday. So I had to be, I had to hack a little bit together to show you what you will see in a few moments. So, as I've said, I have built 2 PowerShell modules. Is it big enough? Or one step further? Okay. What I've built are 2 PowerShell modules. One is PSMPy tools. This is a tool with a module with which you can install any MicroPython firmware from the MicroPython homepage via a bunch of commandlets on any ESP32S3 device right now. I skip this because it's not so important for this talk. If you are interested, we can talk about it later. The most important part for this talk is a PowerDeck module with which you can install the firmware for especially this ESP32 touch screen and install the necessary Python scripts to run on this device and later on to use what you are seeing on the device. I have here included the URL of the firmware for this device. I run it. Download it. Perfect. And now I challenge the demo god for installing this firmware on the device. By the way, I have here a camera to show you what's on the device in a few moments. Right now it's simply black because when the firmware is installed, you can see nothing on it. If you have a native ESP32 chip, some LEDs are blinking, but these LEDs are on the backside covered, so nothing to see. So now the firmware is installed. Let's do a first test. I switch to Tony. This is an IDE for Python, similar to the ISE and PowerShell. You can do the same with VS Code extension, but since I'm not so familiar with VS Code right now in different environments, I use a simple approach. So this is running MicroPython with an LVGL library on this device you've seen a few months ago via the camera. So this is a first check that everything is fine. Now back to PowerShell. We can also check from the PowerShell side or not. Oh yes, I have not closed the Tony environment. Under the hood, the communication runs over the serial port. And the serial port can only be opened by one process at any time. More to say, it's only possible to have a serial port open from one thread of a process at one time. And this is a problem I had 2 weeks ago, which I needed to fix. So I have to close and not only to hide the Tony environment. And now, perfect. So now from the PowerShell side, we can see what is installed on the ESP device. We can see there's an ESP32, there's a MicroPython release, and somewhere below is the version of LVGL. this was important for me to find out which LVGL is installed with this firmware, because there are a few LVGL versions around, and we are now at version 9.x somewhere in this area, and the API calls have changed a bit. So it's important when you look in the documentation that you have the right version number of LVGL. For MicroPython, it's on its own, it's not so important. It's evolving also, but that's not so important if you have MicroPython 1.19 or 1.20. We are now at 1.25. But when you compare it to Python 3, then there are more differences. So you have to concentrate on MicroPython. Okay, so we now see that we can communicate with this controller from the PowerShell side. What we can now do, just a quick look back in the Tony environment. In the lower left window, you can see there's only one Python script right now on this device. This is a bootpy, which is required to start something. We now install the PowerDeck scripts to the device. This takes a few moments. I've put on verbose, but we can see we will see it in a few moments when I switch to Tony back again. If you have any questions around, raise your hand and yeah.
You said under kind of application like accessing the server both at the same time, but there you are.
No, Tony is not open in the background. I've closed it. This is important because this simply does not work. And this is a problem with when I started this project. I started it with as a script. Playing with these APIs, with that APIs, and so on. And so I had a bunch of scripts of lines combined, which are more MicroPython related and which are more related to my project, this PowerDeck project. And when I came to the point that I was sure this is possible, what I want to do, I started putting it dividing it in two modules. Then I came to the problem, what I said, that well, when I do this in the one module, open the port for MicroPython and need to communicate from the PowerDeck module, I have to find a way that I have only one serial port instance open, which I can manage over multiple modules. And I've got some ideas from the talks yesterday or the day before yesterday. And so I have some ideas for the next few weeks or months after the conference. And so I have to always have an eye which process is open, so everything works mostly fine. Okay, we've installed the PowerDeck scripts and so on the device. So a quick look back via Tony. And now you can see we have installed PowerDeck JSON, PowerShell file. This is only put on the device because this is not run on the device because in the next step I want that I can take this display, take it to my workplace, take it to my home office, take it to somewhere I want, only install the PowerDeck module on my computer where I'm working, start dash PowerDeck, and everything should work. And so I have to, I need the PowerShell script, which is running the PC part on the device, so that I don't have to use an USB stick or something like this to transport the scripts, the script I want, which defines the GUI. So this is put here, and there's a problem with it, but I have to fix it. So now to go further in the demonstration, I have to do a little hack. So not this, but this. So this is normally not needed when I have fixed the bug. So back to here. So now we have everything installed on the device. And now let's go. So now I have to switch. So what you can now see on the right window is what I've defined as a user interface on with PowerShell. There's something wrong. This is a GUI I've defined, but not what I wanted. This is not what I want. This is not some UI which I have. Just a moment. Just a moment. I have to check something. This is not the right script. This is not the right script. Something went wrong. I hope I can fix it. Okay, when this error occurs, I have to plug it off and on. Well, okay, today the demo god is not with me, but I have to come back to, I need to come back to the command line here in the PowerShell, in the, so I can delete one file and then I can go ahead. Indeed. Okay, I think now we are back in the game. I have to check. This was not the right one. Also not the right one. Yes, this is the one I wanted. So in a few moments we are back in the game. So, hope we are now back in the game.
And the last result of this open thinking to like as without wise patterns.
So one problem I have to discuss with the vendor of this device is when you reboot this device, when you have the MicroPython firmware on it, and have defined LVGL user interface, it's sometimes, or most of the time, it took relatively long to bring the GUI up on the device. If you have the original software, when you buy such a display, plug it in, there's an application installed on it to give you a view what is possible with this device and the user interfaces in these libraries. Then it you plug it in and pop, it's there. And I haven't found out why this does not work with the PowerShell with the MicroPython firmware on it. I have to discuss it with the vendor if they have a solution or know this. But this was not on my top to do. So, okay, now we are back in the game. This is what you can see on the device. So. If you remember what I've shown on one of the first slides, how you can define this GUI. Where is it? This is it. So what you can see on the device is two layers right now. You have, just a moment, you can see nothing. So it's better. You can see layers on the two layers on the device. Productivity and projects. Now I touch here on this device and the layers switch. So in the PowerDeck configuration file, I have defined two layers named productivity and projects. In each layer, I can define a group of widgets. Each widget's commandlet, widgets is an alias for new dash widget. And so on, but so it looks a little bit smoother. So I've made some aliases. Each widget defines a row, and in each widget row you can define buttons. At this time of the project, you can only define buttons because it's relatively simple to do this. The LVGL library allows radio buttons, sliders, checkboxes, almost everything you want or you need in a graphical user interface. So when I go ahead with this project, I'm trying to give the possibility to define a slider or something like this, or a dial for turning the volume. This is everything possible, and I have a device which is original. When someone is interested, I can show you later what possibilities this graphics library brings to us. Right now, there are only buttons and there are only text buttons. It's principally possible to put images on these buttons, but not at this state of the project right now. But I think for a rough idea what's possible, it's enough. So you can define the buttons, you define the button label, and you can define what should happen when you press such a button. And I have put a few things below. Can try it out. What happens? Where's my notepad? Let's do a new notepad. So my focus is now in the notepad. And when I press a button on the display, the text I have defined as an action for the footer ticket. This is something which I'm trying out for my company, where I work with a ticket system. Sometimes I need an other footer for the ticket system. There's no automation like you can define in Exchange or in Outlook for different things. I need different mail or ticket footers. So this is only an explanation what can be done. And in the session proposal, in the abstract, in the schedule, I have written that I have a certain module built, a PS keystroke simulator. I came around that this module is not necessary because I can simply use .NET calls under the hood, Senkeys and so on. When I started this project, I had a problem where I thought this does not work, so I started the other module, but I will decline it because it's not needed anymore. So if we can go ahead, we can use other actions. And so you can type something what you want. This is relatively simple. My first approach with this project was to find an ESP touchscreen which can simulate a keyboard or a mouse on its own. There are devices around, but then I need device that supports MicroPython, because it should be simple to put the firmware on it, because I don't want to compile already at any time a new firmware for the device, simply copy files. So I needed a MicroPython, I needed a GUI library, for example LVGL, and I need the possibility that the device supports human input devices, keyboard or mouse. And these three, I haven't found such a completely made device. You can make it on your own. If you have a touch screen, if you have an ESP32 that supports HID, that's no problem. But then you have to solder and maybe build your own closure for the device. So this is buy it, plug it in, use it. So I had another challenge to how can I simulate keyboard input. This is quite simple. And then I came to the idea, well, maybe it's good that I am I can not only use it as a keyboard interface, because now I can run any action I want on the PC. because keyboard actions is a simple thing which I have done here, but I can do more complicated things, because this is simply a script block where I can put anything in it I want. And in my home setup, or in my work setup, for example, I have 3 displays. I have my notebook display and 2 external displays. And sometimes I want to do a screenshot from exactly one screen, the left screen, the right screen, the screen in the middle. There are solutions around it. Some screenshot tools you can define. When I press this button, do this. When I press this button, do this. But they are only limited to do a screenshot from something, from some screen. And here I can put a screenshot from one screen. And when I've done the screenshot, I can do some actions immediately without pressing any other button with it. And so I thought, well, it's not that problem. It's even better that I haven't got the easy one I wanted in my case. So I've simply put around some actions. We can try out when I copy. Give me a moment. No, this is not so good for a demonstration. Clipboard image. We do something. I will do. Hello? I want to do a screenshot. So now I've done a screenshot, and now I have the button Open Clipboard Image, and DemoGod is with me. Under the hood, the definition is take the image from the clipboard, put it in my defined image editor, and so I can work on it. Whatever you like. Possibilities are endless. So this is what I've done. Open Clipboard Image was the button I've pressed. I have command-let save clipboard image. Open with my favorite program, in this case Paint.net. And now you may ask, where is this command-let save clipboard image from? Because it's not a standard. When I showed this demo, I skipped directly to the layers section. But in the definition file, of the PowerDeck definition, you have a section action prerequisites. In this action prerequisites, you can define any functions, you can import any module you want to make it usable for these button presses. And so the function save clipboard image simply is here. Why I've done this? Because I want to have the possibility to define one script file, one definition I can put on my device, take it with me, as I've told earlier, and I'm happy. This is the way. So this is for this. A few more words about the layers. I have defined 2 layers I have set. The number of layers you can define, well, it's only limited by the number of memory of this device, because under the hood they are stored as a JSON definition on the device. And this is a text file, and this is relative small. In the layers you can define almost as many widgets as you like. There are a few limitations depending on the screen size, which is usable and which is not usable. This is a 7-inch device with 800 x 480 pixels. So I have calculated the best possible grid. It's 5 rows, and that's fine. So what you can see is right now I have a tab like layer switching mechanism on the left side. I'm a right-hander, and so for me it would be better if I have the device on the right side of my of my keyboard, that I have the tabs on the right side of the display. This is no problem. You can switch it on the right side. This is right now, it's for demo or testing purposes. But I will, I've built it for demo and testing purposes, but I think I let it in the final functionality, because when you have only one tab style defined, then this selection window, this selection box disappears, because when there's nothing to select, you don't need it. So when you have tried out, or when I've tried out everything and I found my final best practice solution, then I simply define the style I want, and bam, that's it. So simply for completeness, you can put the tab styles tab on the top, and you see that the little selection box flips around. It's so that it's best available, that all other buttons are best available. And there's a button. This is obvious. And you may have seen the window button. This is another style which is possible with the LVGL library, that you have a window like visibility. And now you can switch around with these buttons: productivity and projects. So we have almost a countless number of possible layers. You have a number of button styles. They are computed automatically from the LVGL library under the hood, so that if you have in one row you have 2 buttons or 3 buttons or 4 or 5 or whatever, it looks fine. Now there's a very complex rendering mechanism under the hood, but I don't have to do it in PowerShell or in Python, because it's everything done from the library. So I think I've covered most of the features I wanted to show. Maybe something. I have a button list here on the below. I can't remember the shortcuts for creating a new desktop. Okay, I can do it with a mouse. Works out. Next desktop. I can flip around the desktops. And the nice thing with this is, I've tried out if such a functionality is possible to control via PowerShell on an external device. When you define such an user interface, like I've now on my external device as a PC application, you can define with Windows Forms, with WPF, an app with PowerShell. Everything is known, but you have to switch focus. Always when you press a button on the PC side, the focus switches. And when you then want to run an action and key press or something like this, and then in the app, you have lost focus a few moments ago, you have a problem. Now, when I have everything on my PC side, window is open, I press a button on the external device, and the action goes directly to the window I've opened on the PC side. This is, in my opinion, an advantage of this approach than building an application or script or a user interface on the PC side. So that was it for now.
Just for me to understand and to recap a little bit.
Yeah.
So this is like you have an external screen connected to your PC because the code still runs on your PC. Because
yeah. Yeah, it's okay. The question was for the recording. Is it kind of an external device? Yes, it is an external. It is an external display, but this is another kind of external monitor display if you plug it via HDMI or so, because it's more like a keyboard display, or and the talk I have named it converting ESP powered touchscreen device into a Stream Deck like productivity gadget. I don't want to advertise Elgato Stream Decks, but some of you may know there exists these Elgato Stream Decks, which many YouTubers, Twitch streamers, and so on are using for content delivery. They have an external device with some external keys, which you can define a little image on it. And this device is also has also a mechanism for layers. So you can define one key press on this external device and switch the layers. So all buttons on this device bring up another functionality. But this only works, as I know, with simulating other actions. And I want to compare it more to this Stream Deck devices than to an external display, because right now it's not possible to, for example, take one window and push it to this external device. So it's more like a keyboard. It's a completely free definable keyboard, which you can start actions on the PC. And this with this focusing thing.
So we heard about the Stream Deck functionality side, but what is your intended final goal for the fully developed product? Like, what are your use cases you want to use with this little?
My use case is what mostly what I have on this first screen, on the second screen, this print screen functionality, for example, because at work I have one screen where I have my WebEx session, always my WebEx session, because when I'm in my company we use WebEx. If it's Teams, if it's Zoom, if it's something else, I would have I would put the video window on one screen, and I put my presentation desktop on the other screen, and other thing on the third screen. And I often come around that I want to a screenshot from this, or something like that. And maybe I want to take, because sometimes sessions are not recorded, so I want to take a screenshot and take some notes for this screenshot, because sometimes not all is on the slides what you want to note for it. So I have the possibility to take a screenshot from one screen and immediately let open a notepad or a Notion tool or something like this to exactly write down some notes for this screenshot I've taken, to be more productive and not flip around with some keys or mouse or another app or something like this. Another point is we have many different apps which are not so perfectly combined. So I take a ticket number from one system, from a mail. I have to go to a browser window, enter the ticket number into a field, and so on, or take a link from somewhere which is not a URL from somewhere which is not a link, which I can click and automatically go to the browser. So I have this, I called it the magic on clipboard or magic on selection button. I select something in any app, press this button, and depending on the regex matching I have done under the hood, the right application starts up with what I want to do. Or on the products layer, I work on many different projects in my company, and I ran out of time. And if I want to write down for which project I'm working now, then comes a telephone call, there comes a video call, there comes a colleague from the bureau next to me, and if I write it down by paper, for whom have I worked? It would be nearly impossible to track this. And so I got the idea to give my manager an idea what I'm doing the whole day when some projects are not going so he wanted it. I thought, well, if I have a simple display where I can click start project now, do this, do that, do that, and simply write a small script later, which says, okay, there I started this, then I came that. So I had 5 minutes for the telephone call for this project, 10 minutes for a video call for this. I have almost no overhead for tracking these informations with such an approach. These are some ideas, and mostly these projects, like the matrix clock I've presented yesterday, is a Pocha Kucha, starts as an fixed idea, and later it turns out what it's usable for. So I'm a gaming kid, so.
Could you show us the other controls we can display on the screen? Even though I understood that it's not implemented yet.
Yeah. Okay. Okay, the question was if I can show which controls are possible, even if they are not implemented right now in this project. I have to go to the LVGL.
Because I am a home assistant user, so I wonder if I can maybe use it to display something.
Yeah. Yep. Yeah, possibilities are. Okay, I stop this. So this is the LVGL documentation. So let's have a look. There's a calendar widget. There are chart widgets. There's a color wheel. So you get a rough idea. This is almost everything you need in a modern graphical user interface. Controls are there. And what's really nice is with this LVGL when I came around and thought, well, it would be perfect if I can find a firmware for such a device which combines MicroPython and LVGL, because it's really, really simple. These Python scripts I have built, which are running on the device here under the hood. This took me a week or two to find out how it works. And when you have done the first steps, you may come into a flow, and it's quite easy. And I somewhere have a link where you have an LVGL online simulator. You have a website where you can paste your LVGL call, your MicroPython LVGL call in it, and try out some functionality, how it works out. This is really cool. This is not perfect, because I haven't found out how you can synchronize the resolution from this browser LVGL simulator to your device's device's resolution. So 800 x 480. It's a bit smaller on the website, but it helps extremely to find out what's possible and how to use it. You have a spinner, so you have almost everything. You even have a keyboard. You can display a keyboard on this device, and this is all event-driven. So if you've ever done development with a graphical user interface on the PC side or any other side, you will find out relative fast how it works. And so, yep.
I could also notice that you had a button on there for Intune. What does that do in that context?
Nothing. This is simply a no. This is simply a project. A project I am working on implementing Intune in our environment. So there's under the hood. Where is it? This is the page where I only track the projects I'm working on. So I simply, as a set project, is simply write this text with a timestamp into a JSON file, and that's it. Exactly. Only this, but it's you can put everything you want under it. Under the hood, this is maybe I haven't mentioned it. The communication under the hood is completely over serial port and via JSON. There's small JSON snippets were exchanged. Right now, this is only a one direction. This is I press a button on the display, and there goes a JSON request to the PC side. This button was pressed. The action text, what the script should execute, runs on the PC side and is defined on the PC side. In the final, when I'm completed with it, I've shown that the PowerShell file, which includes the definition, is stored on the device. I load it when I run the commandlet start PowerDeck. I load it from the device, interpret it because it's a simple PowerShell script, and execute it when the JSON request comes in. Thank you.